Hi guys, today's video is about getting started with digital multimeters. It's a demonstration of a number of different multimeters and then methods by which they're handy around the house, can save you money as regards checking batteries, fuses, bulb, etc, etc. I'm trying to work off notes today now to try and keep the subject matter fairly straightforward and reasonably short. Now on the desk here I've three different multimeters laid out. The one on your left is a budget multimeter, the one in the middle is sort of mid-range, and the one on the right is a more professional unit. The budget ones start off anywhere 18 to 20 euros, 20 to $25. Middle of the range ones then would be 50, 60 euros, which would be $60 to $65, and then you can go to many hundreds or even thousands of euros or dollars for specialist multimeters with graphical displays and other functionality which is not necessary around the house. So for the purposes of getting started with a multimeter around the house, I'd recommend a little budget unit, $18 to $20 or maybe 15 to 20 euros, somewhere in that category. When you are buying one, I'd recommend that you make sure that you buy one with a little stand at the back, because generally speaking you'll be taking your measurements with the meter propped on something and using the test leads then to actually take the measurement. Now, as regards the symbols, which can be quite off-putting on the face of these, we'll go through those now and give you an idea of what they are. Now, I'll use the middle of the range one here. It has the clearest writing on it. So now, what we look at here is the face of it. The dial corresponds to individual sections on this, like you turn it depending on what you want. The one that we'll use the most, or the two sections that we'll use the most, are the one labelled ohm here and the one labelled DCV. Ohm measures resistance, and I'll come back to that in a while now, and it's related to continuity. Again, I'll come back to that. DCV, direct current voltage, and the range that we'll be measuring in will be either 2 or 20, depending on whether we're measuring a car battery or a small household AA battery or a 9-volt battery, whatever. ACV down here has a range as well. And that stands for alternating current voltage, which is more related to household voltage. And again, there's just a number of ranges within it. As it stands at the moment, we won't cover anything to do with household voltage. Next section over here is AC amps, which is alternating current amps, and that measures the current or the volume of electricity going through a circuit. And over here then we have DCA, which is the direct current amps, and again that measures the volume of current going through a circuit. There are other little sections as well, like a diode tester or high frequency measurements. We don't need to cover those at this particular stage. Now, down the bottom of the test meter, and pretty much every test meter, you'll have a number of slots that your test leads go into. The black one, and this is sort of a fairly industry standard, will always go into COM, which stands for common, and the red one for our purposes will go into V slash I think it's an omega, that measures resistance and continuity. The other two slots over here are for measuring amperage, and what has to happen then is that the multimeter has to form part of the circuit to measure the flow of electricity going through a circuit, and it's different wiring inside, and a lot of the time it's also fused as well to protect the multimeter from overload. So what we'll do now is I'll hand you over to our special reporter from our outside broadcast unit to give you a report on the current conditions. Now, here I have three batteries demonstrated. They're all 12 volt, and the small one is from a rechargeable torch. The medium one is from a small lawnmower, and the biggest one at the back here is from a Jeep, 3-litre diesel engine Jeep. Now, just to show you the fact that they're all 12 volts, we have a little light set up on our professional test rig here with little jumper cables, and when we connect we can see that the light lights. it doesn't blow up when we connect it to the bigger one. And that will just demonstrate that voltage, right, is one component of power. Okay. Now, to give you an analogy, if you take a garden hose, water can flow through a garden hose at a particular speed, and it'll give you X amount of volume then per minute or whatever. If you take a large river traveling at the same speed, you have a much, much larger volume of water in the same period of time. So the same principle applies to batteries. So this small one here is 12 volt, 7 amp hour. The medium one is 12 volt, 14 amp hour. And the very large one at the back then is 12 volt, 102 amp hour. So you can see the logic that voltage does not describe the power of a battery. It's the current is a key component, and current roughly equates to the volume of power that you can get work out of. Okay, hope that explains that. Back to the studio. Now, thank you for that special report. We're back here in the studio, and what we're going to do now is just do a demonstration of a number of basic units or uses of the digital multimeter. So what we're going to do is check a number of batteries. We're going to check a number of light bulbs. We're going to check a number of fuses, and I'm going to do a very short demonstration as well of just a very basic electric circuit. Now, these are all low voltage applications, and they don't expose us to risk. Obviously, the first rule of Digital Multimeter Club is not to stick our digital probes, or for that matter, our probing digits, any place they don't belong. That includes wall sockets. So I guess that's today's teachable moment. Now, what we'll do is we'll turn on our multimeter and we'll test the two sets of batteries first. So what we do is, and I hope we can see this fairly clearly, yep, right, what we do is we move our selector over to DC volts, which is DCV, and in this particular instance we're going to set it to a range of 2 because we're testing a 1.5 volt battery. So I have 2 batteries here. One is good, one is not good. So what we'll do, generally speaking, we use the red probe to test the positive side of a battery, and the black probe to test the negative side. It doesn't have a huge bearing on it, because what will happen is that you'll get a negative reading as opposed to a positive reading, but you'll get pretty much the same reading anyway. So we hold one side of the probe to the top of the battery, one side of the probe to the bottom of the battery, and we're getting 0.309 volts on our multimeter. So that tells us that this particular battery is well used or beyond use. So put that aside. Now the next battery then, just by process elimination, is going to be the good one, and we'll measure that again. Again, the red probe to the top of the battery, the black probe to the bottom of the battery, and what we're getting there is a voltage measurement of 1.605. Now, generally speaking, when these batteries are brand new, they give you a voltage reading of anywhere between 1.6 and 1.65 volts. So we know that that's the good battery, so we can throw away the old battery and keep the new battery if you're like the rest of us and you have a jar of batteries and you're not too sure whether they're good or bad. So that's the 1.5 volt batteries. Now the next item on our list will be 9 volt batteries, and again these are used in smoke alarms and all sorts of applications. What we'll do here is we'll move our multimeter. Again, we're staying on DC voltage, but we're moving it to a range of 20 because the 9 then fits in between 2 and 20. From a measurement perspective, the logic behind the ranges is that it gives a more precise measurement within that range. So what we'll do is we'll stick our test leads on the battery, and you'll actually see on the battery there there's a little plus on this side, which means that the other side is minus. So we'll stick our battery down. We'll stick one test lead on the plus side, one test lead on the minus side, and we're getting a voltage measurement of 3.28, and this is a 9 volt battery, so that tells us that that battery is gone, or well on the way to being gone anyway. Now again, this battery, slightly newer, has a plus on this side to demonstrate that particular terminal, and it has a minus on this side to demonstrate that terminal, so you'll know which way to put your leads. So we put the red one on the positive side, the black one on the negative side, and we're getting a voltage reading of 9.5 volts, which tells us that the battery is good. Now, just to demonstrate, if we move the battery around and we reverse our probes, what we'll do is we'll get a voltage reading of minus 9.5 volts. So it's not the end of the world if you put your leads on the wrong way. All you'll do is get a minus reading as opposed to a plus reading. Now, following the report from outside, which demonstrate a current, the voltage measurements then on our batteries, what we looked at then is continuity, and continuity tells us that there's a circuit that these test probes can run a signal through. So we'll move our multimeter over to ohms, right? And generally speaking, I'll get my little stick out, a lot of multimeters have next to the range of ohm values a little musical note or the sound or a picture of a little speaker or something like that. And what that does is it gives us an audible tone when there's contact made around the circuit. So I have my multimeter turn now to the little musical note there. And what we'll do is we'll touch the two leads off each other. And at that point then, we're getting a resistance reading of 0, and we're also getting an audible tone. Now, different meters have the audible tone set to different ranges. So if we got a reading of 5 ohms, which is a very, very low level of resistance, that will tell us we have a decent circuit, but the little beep might not go off. So just to bear that in mind. Now, what we have here is 2 very small fuses. This one is obviously blown out, and it's you can see smoke inside it. So what we'll do is we'll just put one side of one probe on one side of it and the other probe on the other side of it, and we'll get no circuit. Okay, so that's the bad fuse. And then we have a new fuse here, which is 10 amp, I think, but that's not really relevant. So we stick again one digital probe or one probe on one side and the other probe on the other side, and we should get the audible tone this time and an ohm reading. Okay, so you'll see there it starts out with a small bit of resistance and falls to 0 and triggers that audible beep. So that tells us, especially in fuses which are particularly difficult to see, it's okay with this one, or it's very obvious with this one that it's blown because it's all blackened and burnt out. Again, the same principle applies to light bulbs. Now, here we have 2 light bulbs, and these are automotive light bulbs, came out of a trailer. I think one is blown and I think one is good, but again, we don't know. And from a visual inspection, it's very, very difficult to tell sometimes whether light bulbs are blown or not. So this is where the multimeter will come in and stop you wasting time trying to get a light to work when the bulb is bad, but you can't actually spot it. So what we'll do is these particular light bulbs, this is a single pole one, right? We stick one probe against the side of it, which is one terminal, and the other probe against the other terminal. Right, so what we're getting there is actually 1 ohm resistance, which is not surprising, but we're getting our audible tone, which tells us that that bulb is good. Now, next bulb then is this one here, and this is the one I think is blown. So we'll test that now. Again, one probe on the metal cladding side of it, and the other probe on the terminal at the bottom. And what we're getting there is no continuity whatsoever. And if you're ever worried about the battery in your multimeter, you can always just test it yourself with the 2 test leads. So that's batteries, fuses and light bulbs. And we'll just go on to a very basic circuit now, just to demonstrate how to do some very straightforward troubleshooting. Okay. Now, here we have a very basic electrical circuit. I'm using a small power supply to substitute for a battery, a car battery in this particular instance. We have it going through a small switch into a 12 volt light bulb then. So if we turn the switch on, light bulb comes on. Fairly straightforward. Now, from a diagnostics perspective, if you're looking to trace a circuit, there's 3 different items then to check. Possibly 4. Number 1 would be whether the circuit is getting power. Number 2, whether you have a break in a wire. Number 3 would be any switching mechanism. And number 4 then will be the light bulb in this particular instance, or the end user of power. So we have our stabilized power supply switched on. And what we'll do, the first step in our diagnostic procedure will be, we'll take our test leads and we'll examine that. So in this particular instance, the white wire is the positive circuit and the green wires are the negative circuit or ground in a car. Now, just to be aware that in a car or any automotive use, there isn't 2 wires going to every single electrical circuit. What happens is the battery, the negative pole on the battery is strapped to the chassis of the car, and it uses the metal chassis of the car as one of the lines of the circuit. So if you come across some piece of equipment in a car and there's only 1 wire going into it, generally that's a positive wire, and the other or the negative connection for that piece of equipment will be a direct connection onto something of metal like the steel chassis, or you might see a ground wire going to the chassis from that particular circuit. So just to be aware of it. But in this particular instance, we have a separate positive and a negative. So we have our multimeter set to DC volts in the 20 volt range, and we'll just put our test probes on the two terminals, and we're getting a reading of 12.48 volts. So that tells us then that we're getting power to our circuit. So there's something else wrong. It's either a cable, a switch, or the bulb. So what we do then is we can go back to our ohm or continuity testing and move our dial over to that. And we'll just do the white wire first. So we touch one side of it at one end of the white wire, the other end of it at the other end of the white wire, and we're getting a continuity check there, and that audible beep tells us we have continuity. So in this particular instance now, we've 2 wires relating to the switch. One is going from the terminal to the switch, and the other one is going from the switch then to the particular item that we're checking or trying to get to use. So what we do here, we're still set to continuity. We'll test the green wire going from, better make sure we're testing the right one. Yeah, the green wire going from the terminal to the input side of the switch. Okay, and we have a positive continuity there, which tells us that our wire is good. And we'll take it from the outside pole of the switch and test the other end of it here. And again, we're getting continuity. Now to test the switch, it's exactly the same thing. We'll just take these 2 wires off here now. Now our switch is off at the moment. Okay, so these 2 poles here are the connections, and if we test those, we get nothing. But if we flick the switch on at the same time, we're getting continuity then. So that tells us then that the switch is making contact across those 2 poles. And generally speaking, some switches will have 2 poles and it'll be a very simple connection. Other switches then will have 4 posts, which gives you a plus and a minus that you can actually run through the switch, and that just separates the 2 circuits, positive and minus, depending on the circuit that you have. Now that we have our switch tested and it comes back as working positively, we can test the bulb in the circuit at this point now, and we can either take the bulb out or we can actually measure it in there. So if we touch one electrode to the casing of the bulb and the other electrode underneath, again we're getting a continuity or positive continuity check there. So that tells us that our in this particular instance the circuit is working. But obviously if the bulb wasn't working, that would show up. The cables weren't working, that would show up, and the switch not working would show up too, plus obviously the power supply. The slight difference, and I meant to mention it earlier, is that in a car, as I said, the chassis forms part of the circuit, but if you're checking trailer lighting, the chassis on the trailer does not form part of the circuit. You'll have a separate wire for positive and a separate wire for negative on a trailer. Okay, I hope this video is of use to somebody. I know there's a lot of getting started with digital multimeter videos out there, But what I find is that when I look for something on YouTube specifically, I'll look at a number of different videos, and there might be a piece of information in one which mightn't be in another, and vice versa. And I hope that this particular explanation might help somebody somewhere just get started with a digital multimeter. They're very, very handy bits of kit to have around the house for checking batteries, fuses, bulbs, and then obviously then there's a whole lot more to it then in the automotive side. So best of luck. Thanks for watching.